Hi everyone, my name is Daniel Dunfee and I'm an undergrad here at Ohio University. Today I'm going to be talking about my honors thesis research on skull growth in Dryosaurus, a species of small, plant-eating bipedal ornithopod dinosaur. And so I'm looking at three skulls that represent a baby, a subadult, and a partial adult skull, all from the Upper Jurassic Morrison Formation at Dinosaur National Monument. We jokingly refer to these three as baby dry, mama dry, and papa dry. My goal is to use CT analysis in order to explore their skull anatomy, as well as to study change with growth, which is called ontogeny. All three skulls were CT scanned, and then were analyzed using the Amira software. And so getting into the results of some of that analysis, I'm actually comparing baby dry to a juvenile of a closely related species from Africa that's similar in size. My initial results showed that baby dry actually had 3 more upper teeth. Looking at change with growth, CT analysis really allows us to peer inside the fossil and to count the individual tooth position numbers, and to document that mama dry actually had 8 more teeth than baby dry. Likewise, in people and puppies, we know that babies tend to have relatively larger eyes and skulls than adults. My CT-based measurements confirmed that Dryosaurus also followed this common vertebrate train. CT of baby dry also allowed me to discover bones that were buried in the rock and that nobody had ever seen before, like this bone behind the eye socket, as well as the first bony eye ring in Dryosaurus. In baby dry thus far, I focused primarily on the bones surrounding the brain, called the brain case, shown here in isolation. By studying these brain case bones, we can get a better sense of the brain itself. And so the next step of my project is to take those brain case bones and generate from them a 3D model of the brain itself, called an endocast. Other members of Whitmer Lab have already made an endocast for mama dry, which allows me to study the change in brain shape between baby dry and mama dry. So in summary, CT scanning really allows us to better understand the changes with growth in these dinosaur skulls. All 3 specimens were CT scanned for the first time, allowing for 3D visualization of individual bones in the juvenile. CT analysis revealed previously undescribed anatomy, like the first known scleral ring in Dryosaurus, as well as ontogenetic changes in tooth position number, relative orbit size, and soon brain shape. Thank you all for watching.